So here I've been asked to factor x cubed plus 6x squared plus 11x plus 6. And this was suggested by a viewer named Troy S. And if you comment again, I'll pin your comment down below. Thank you for this suggestion, by the way. And I'm going to use the rational root theorem, but the other method that Troy suggested was by grouping. So if you want to use that method and comment it down below, that would be great. Like I said, I'm going to use the rational root theorem. And I have a video on the rational root theorem. I'll try to leave it in the cards if I remember to. But essentially what it says is the possible roots, or the possible rational roots, are equal to the factors of 6, so that's plus minus 1, plus minus 2, plus minus 3, plus minus 6, over the factors of this coefficient in front of our leading power of x. So here that's just 1, so we've got plus minus 1 down here, which means that our possible rational roots are plus minus 1, plus minus 2, plus minus 3, and plus minus 6. I'm going to use synthetic division to test this root x equals 1. And if x equals 1 is not a root, then maybe I'll use long division to test x equals negative 1 or x equals positive 2 or something like that. And we'll just go from there. So let's test this root first. So we have a coefficient of 1 attached to x cubed, a coefficient of 6 attached to x squared, a coefficient of 11 attached to x, and then a coefficient of 6 here by itself. And I could pretty quickly see just by looking at this that 1's not going to be a root, because we'll get 1 times 1 is 1, 6 plus 1 is 7, 7 times 1 is 7, plus 11 is 18, 18 times 1 is 18, plus 6 is 24, which is not 0, which means that this 1 is not a root. So let's change this to negative 1, and then we'll test this again. Okay, so let's test negative 1. So we bring this number down first. 1 times negative 1 is negative 1, so 6 minus 1 is 5. 5 times negative 1 is negative 5, that leaves us with 6 here, and then 6 times negative 1 is negative 6, and we get 0 here, which means that we have no remainder, and this factors as x plus 1, that's because we tested negative 1 here, times x squared plus 5x plus 6. So let's get rid of these calculations, we'll bring this up, and then we'll finish it off. Okay, so very quickly, I want to test that this factorization works. So we'll factor x all the way through this. So we'll get x cubed by x times x squared, plus 5x squared by x times 5x, and then 6x from x times 6. And then we'll get plus x squared, that's by 1 times x squared, 5x by 1 times 5x, and 6 from 1 times 6. But now combining like terms, we have 5x squared and x squared, so that gives us 6x squared. This x cubed is our only x cubed term. And then we have 6x and 5x, so that gives us 11x, and 6 is our only ones term, and that matches up perfectly. This expression and our blue expression here match up perfectly. So now we can factor this in a couple of different ways. I'll continue with the rational root theorem, and we have the same possible rational roots as before. We have 6, 3, 2, and 1. We already know that 1 is not a root, so maybe let's test negative 1 again. So if we test negative 1 again, our leading coefficient is 1, and then 5 is attached to x, and then 6 is our final coefficient. We bring this down again, and then 1 times negative 1 is negative 1. 5 minus 1 is 4. 4 times negative 1 is negative 4. And then 6 minus 4 is 2. So this is not a root. X equals negative 1 is not a root of this polynomial that I will underline in yellow. That's what we're testing here. Okay, so let's maybe get rid of this, change the negative 1 to a positive 2, and we'll keep going. Okay, so now we're going to test positive 2. That's just our next possible rational root that we outlined up here. So bringing this 1 down, we'll have 1 here. 2 times 1 is 2. 5 plus 2 is 7. 2 times 7 is 14. And then 6 plus 14 is 20. But 20 is not 0. So that means 2 is not a root of this yellow polynomial. So let's change this to negative 2 and we'll try again. Okay, so we bring this 1 down to start. And then we have 1 times negative 2, but that's going to be negative 2. And then 5 minus 2 is 3. 3 times negative 2 is negative 6, and 6 minus 6 is 0. So we have x plus 2 times x plus 3. That's what we get left over from these two coefficients down here. And then we have this x plus 1 from above. So our total factorization of our original expression up here is x plus 1 times x plus 2 times x plus 3. And if you've had plenty of practice, this factorization of x plus 2 times x plus 3 was probably pretty obvious from this quadratic expression right here, but it's nice to see how we can work this out with the rational root theorem and synthetic division. And that's enough for now.